G'day folks, I'm just going to do a bit of introduction to rationalising the denominator. So what do you mean by rationalise? Well, a surd is with what we call an irrational number. A surd can't be written as a fraction. There's no way to write root 2 as one number over another, for example. One whole number over another whole number over another. So if I look at something like this, for example, 3 over root 10. Well, in 3 over root 10, my denominator is an irrational number. It's a surd. Okay, we don't like irrational denominators, so we like our denominators to be rational numbers. So I've got to fix that up. Okay, I've got to do something about it. Now, I'm going to do more working out in this than we do in a normal problem, right? So don't look at this example and think, oh my goodness, I'm not going to do all that work, right? Relax. I'm going to do more here just to explain every detail of what's happening. Then I'll do another example where I show you just what's required in a normal question. So you wouldn't disagree with me that 3 over root 10 is exactly the same as 3 over root 10 multiplied by 1. If I multiply something by 1, it doesn't change. Okay. Well, then in that case, you wouldn't disagree that 3 over root 10 is 1 divided by 1. Sorry, 3 over root 10 times 1 is the same as 3 over root 10 times 1 over 1. You wouldn't disagree because 1 over 1 is just 1. Okay. And then look at 1 over 1. Any fraction where the numerator and denominator are the same number is basically equal to 1. 7 out of 7 is 1. 4 out of 4 is 1. Minus 10 out of minus 10 is 1. Minus 3 out of minus 3 is 1. 11 out of 11 is 1. 0.7 over 0.7 is 1. If I've got something over itself, it's always going to be 1. Okay, so what I'm going to do is I'm going to write that, just turn the sound off over here so it doesn't bother us. What I'm going to do is I'm going to change this 1 over 1 into root 10 over root 10. Root 10 over root 10 is 1, right? Because you get one thing divided by itself. The answer is going to be 1. Right? So far, this thing here is exactly the same as that thing over there that we started with. So, what now? Get out of here. Look at those flies. Oh, actually, it's a little bee. That's fun, isn't it? I'm going to whack that one away because that'll make for the wrong kind of viral YouTube, the one that I don't want to put out. Okay, so now look at this. 3 times root 10 is 3 root 10. Root 10 times root 10, well, the square root of 10 times the square root of 10 is 10. And now look, our denominator is rational. Okay, so what we did was we had 3 over root 10. We ended up multiplying by root 10 over root 10, and that gave us a rational denominator. So obviously there's more here than we need in a normal problem. So let me erase this and I'll start again with a simple example and we'll build up to some more complicated ones. So let's say I had 6 over root 2. Okay, well, what I need to do is I need to multiply above and below by root 2 because I want to get rid of that square root 2 underneath. So I'm going to multiply by root 2 over root 2. There's that little b come back. Great. Okay, so now look what I've got. I've got 6 times root 2 is 6 root 2. Root 2 times root 2 is just 2. And in this example, I can actually simplify further because I've got 6 over 2, or 6 divided by 2 is 3. This equals 3 root 2. Okay, so whatever surd is in my denominator, I multiply above and below by that. If you're thinking, then there should be a very obvious question come to mind. Well, Mr. Obeid, what if it's not just a surd? What if there's a number out front? Let's look at an example. So let's say I had 3 over 5 root 7. Okay, well again, what I do here, I've got 3 over 5 root 7, and I'm going to multiply above and below. I could multiply by 5 root 7, but I don't need to. The least that I need to multiply by to get rid of the root 7 on the bottom is root 7 over root 7. Okay, so just the third part. So what does that give me? On top I've got 3 times root 7 is 3 root 7. On the bottom I've got 5 times root 7 times root 7. Well, the root 7 times root 7 is 7. So on the bottom I've got 5 times 7 is 35. Okay, and there's nothing I can simplify out of 3 doesn't go into 35, and so there's no cancellations that I can do. The 7 is inside a third, so I can't cancel the 7 with the 35. That's it. That's as far as I can go. Okay, let's step it up a little bit more. So what happens if I've got not a number being multiplied by my third? What if I've got something being added or subtracted to it? So what if I've got 5 over 2 plus root 10? What happens then? Okay, well now I've got to put my thinking cap on. I've got to remember some of that stuff we learned in the binomial products work that we did. Now, what did we learn there? Let's just flash back to that and then have a look at this. So we learned this identity. We learned that if I've got a plus b times a minus b, that equals a squared minus b squared. That difference of two squares identity. Okay. Now I like that, a squared minus b squared, because if I've got a third and I'm squaring it, well then the third part disappears. So what I'm going to do here, I'm going to make use of this result. I'm going to have 5 over 2 plus root 10, and I'm going to multiply above and below, so it's going to be the same thing on the top and on the bottom, by 2 minus root 10 over 2 minus root 10. I want that conjugate pair where that's a plus and that's a minus, right? Because when I've got that plus and minus, I end up with a difference of two squares. Okay, so let's see how that works. So on top I've got 5 times this group over here. Now you say, oh, Mr. Obeid, you said group, but there's no bracket. Well, there doesn't have to be a bracket. That fraction line, okay, the name for a fraction line is a vinculum. That vinculum in that fraction acts as a grouping symbol. It works like brackets, okay? So 5 times this group means 5 times everything in the group. So it means 5 times 2 is 10, minus 5 times root 10 is 5 root 10. Okay, so again, I'll explain that again slowly. 5 times 2 gives me the 10, and 5 times negative root 10 gives me the negative 5 root 10. Okay, on the bottom, look at this. I've got my this plus that, this minus that. I've got that a plus b, a minus b thing going on. It's going to be a difference of two squares. It's going to be this thing squared, which is 4, minus that thing squared, which is 10. Okay, so 2 squared is 4, root 10 squared, root 10 times root 10 is just 10. So I've got 10 minus, 10 minus 5 root 10 over negative 6. Okay, Now you probably think, well, hang on, well, why is there a negative in the denominator? That's okay, because 5 times root 10 is bigger than 10, so the numerator is negative, the denominator is negative. This number here is actually a positive number. Okay. You'll see examples like this in the text that won't end up with nasty negative answers anyway when you get to do them. I'll do a couple more, and I'll make my next one a little bit juicier, and then one after that juicier still. Okay. So let's say now I've got 4 plus root 3 over 5 minus root 2. Wow, that's different, isn't it? It's more than the other one. I don't care what's in the numerator. I only care about what's in the denominator. I want to rationalise the denominator. I'm not interested in what's going to happen to the numerator, if it's going to be a third or not, okay? I want a rational denominator. So to get a rational denominator, I need to multiply above and below by the conjugate. Remember, the conjugate is that fancy word that mathematicians like to use. The conjugate of 5 minus root 2. So in other words, the same as what's here, but the sign in the middle is different. So it's going to be 5 plus root 2 over 5 plus root 2. So on top, look at this, I just got a binomial product. That's exactly what we did in the last exercise in 4D. And so over here I've got 2D, so exercise 2D. So over here I've got 4 times 5. 4 times 5 is 20. 4 times 2, times root 2, sorry, is 4 root 2. Root 3 times 5 is 5 root 3. Root 3 times root 2 is root 6. Okay, it's a bit of a mouthful, but I didn't care, remember? I wasn't fussed on what was going to happen to my numerator. I just want a rational denominator. Well, my denominator, I've got this difference of 2 squares set up again. So it's going to be that number squared. So 5 squared is 25 minus that number squared. Root 2 times root 2 is 2. So on top, I've got 20 plus 4 root 2 plus 5 root 3 plus root 6. And on the bottom, I've got 23, a rational number. Okay, I've rationalised the denominator. All I had to do was look out for that conjugate pair. Okay, this minus that, this plus that. Okay, as soon as I've got that pair, I've got a difference of 2 squares, I'm safe, I'm home. Okay, let's step it up a little bit more with an even more challenging example. So let's say now I've got 7 over 5 minus 3 root 2. Let me make that number a bit, sorry. Let me make that number a little bit bigger. Let's make it 10 minus 3 root 2, just so we get a positive. And I want to rationalise the denominator. Well, look, now I've got a number in front of I've got a coefficient that's not 1 in front of my third. Okay, let's see what happens now. I'm going to follow exactly the same pattern. 10 minus 3 root 2. I'm going to multiply above and below. I need that difference of 2 squares. I need that conjugate. Okay, so it's going to be 10 plus 3 root 2. 10 plus 3 root 2 over 10 plus 3 root 2. A little bit, we lose a little bit of that simplicity if it was just, remember the earlier example we saw where we had something like, 5 root 7, and we didn't have to multiply by 5 root 7 over 5 root 7, which is multiplied by root 7 over root 7. We don't have that luxury here. We can't just ignore the 3. Okay, we could ignore the 5 here, but in these things where there's a binomial, we don't have that luxury. We need to have the 3 here and here. So let's go through and expand that. 7 times 10 is 70. 7 times 3 root 2 is 21 root 2. On the bottom, I've got my difference of 2 squares. I've got a conjugate pair being multiplied. It doesn't matter if it's, if it's, 10 plus root 3, 10 plus 3 root 2 times 10 minus 3 root 2, or 10 minus 3 root 2 times 10 plus 3 root 2. I just need there to be a conjugate pair. If there's a conjugate pair, it's a difference of 2 squares. It's going to be that number squared, which is 100, minus this number squared. Put a little thought into that. What is 3 root 2 squared? Well, that's 3 root 2 times 3 root 2. 3 times 3 is 9. Root 2 times root 2 is 2. That's going to give me 18. Okay, so it's 100 minus 18. Okay, I can rub that out because you guys can just pause the video if you need to see that for a bit longer. Over here I've got 70 plus 21 root 2 over 100 minus 18 is 82. There's no common factors that go into all of that. So there's nothing I can factorise out and simplify. That's done. Okay. Now, and let's keep on going. Why not? We can get even more complicated. I mean, we are 5.3, right? Let's not muck around. So let's look at one last example. Where I've got 4 root 3 minus 5 root 7 over 8 root 5 plus 2 root 6. Okay, so we've got like the coefficients in front of our thirds all the way through, top and bottom everywhere. It doesn't matter. I don't care. We're looking for that conjugate pair. I don't care how messy the numerator gets, conjugate pair, and I'm just careful with my multiplication because I practice my binomial products. I've got nothing to worry about. So that's going to give us 4 root 3 minus 5 root 7 over 8 root 5 plus 2 root 6 times the conjugate pair of my denominator is going to be the same thing with a negative sign in the middle. 8 root 5 minus 2 root 6 over 8 root 5 minus 2 root 6. Yeah, I just carefully go through doing my binomial expansions on top. So 4 root 3 times 8 root 5, well 4 8s are 32. Root 3 times root 5 is root 15. 4 root 3 times negative 2 root 6 is negative 8 root 18, because 4 times 2 is 8 and 3 times 6 is 18. Now negative 5 root 7 times 8 root 5, well negative 5 times 8 is negative 40. Root 7 times root 5 is 35. And then minus 5 root 7 times minus 2 root 6. A minus and a minus multiplied to give me a positive. It's going to be plus 5 times 2 is 10. 7 times 6 is 42. Now that's a pretty messy numerator, right? Did we even get it all on camera? Yep, we did, great. Okay, and on the bottom I've got my conjugate pair. So it's going to be the square of this minus the square of that. So what's 8 root 5 squared? Think about that. Well, it's going to be 8 times 8 is 64, times root 5 is 5, minus 2 root 6 squared, or 2 squared is 4, root 6 squared is 6. Okay, I'm going to play it safe here, I'm not going to be a hero. So my denominator turns out to be 296. My numerator is 32 root 15. Now look at this 8 root 18. Can I simplify root 18? Is there a square number that goes into 18? Yeah, 9 goes into 18. So think about 8 root 18 for a second. That's 8 times the square root of 9 times 2. That's 8 times the square root of 9 is 3 times the square root of 2. That's 24 root 2. So this is minus 24 root 2 minus 40 root 35 plus 10 root 42. Okay, so now we're not quite done. We're not quite done because we're 5.3, so we're not going to leave it there. No way in the world. Have a look at the numerator. Look at these numbers: 32, 24, 40, 10. Do they have anything in common? Is there a common factor? Is there a number that goes into 10, 40, 24, and 32? Absolutely. 2 goes into all of them. So I'm going to factorise a 2 out of all of that. So if I take a 2 out of 32, I get 16. If I take a 2 out of 24, I get 12. If I take a 2 out of 40, I get 20. If I take a 2 out of 10, I get 5. And now, look, I don't have room on my board for another line, but what we do now is we cancel out the 2 and the 296. And so the 2 disappears from there. 196, we divide by 2 there as well. We end up with 148 in our denominator. So our final answer is 16 root 15 minus 12 root 2 minus 20 root 35 plus 5 root 42. Big, ugly numerator, but I don't care because look, I've got a nice, simple, rational denominator. And that was my goal. Okay, so this is like, I mean, you know, I'd be surprised if there's an example in the text that's that complicated. I've taken you right through the easy, right the way through the complicated. I've got all the confidence in the world that if you apply yourselves, especially diligently to the early examples in the textbook, they'll get you sort of switched on, they'll get your mind thinking about these things the right way. And by the time you get to these in the enrichment questions, you'll have no trouble at all, guys. Any problems, you know what to do. Contact me in Microsoft Teams. Drop a comment below here. Send me an email. Email address is in the comments. Let's have some fun. Good on you guys.